All right, so we are going to talk about the different types of crust, and I thought it'd be helpful to draw this picture. And I will put this on Schoology so you can look at this again, not on YouTube. Um, so here I have the different layers of Earth, and in general, we have the crust, the mantle, and the core. But that is broken down into even more. We have the crust, the lithosphere, the mantle is this whole thing. The asthenosphere is just this part. And then we have the inner core and the outer core. So I felt like this was kind of confusing last week. The lithosphere is the crust and the upper mantle, but it's only the solid part up there. And then once it starts to be able to bend and flow, that's why it's called fluid. That's the asthenosphere, and that's where you have all the convection currents happening right here because the rock or the hot rock down there is getting heated up by this core, moving up, cooling off, sinking back down, heating up, cooling off, sinking back down, and it's constantly going like this. And that's what causes this crust to move. And actually, to make this better, this crust should have some little like pieces on there because you have tectonic plates on here. So I forgot to draw that. So here's the crust broken up onto tectonic plates. And so here's one plate, here's one plate, and I colored them two different colors because there are two different types of crust. There is oceanic crust and there is continental crust. So I just made that a little bit easier with the ocean being blue, and we have one here, and here's your little mid-ocean ridge, and this is the convection current that's causing that. And this is an igneous rock because it's coming from this melted rock down here, and it's spewed out of this mid-ocean ridge, and it's causing a little mountain here, and it's pushing all of these rocks away. And it's very, very slow, but it is moving over a long, long time. You can notice it. So here is the mid-ocean ridge, and it's pushing all the way down, and then over here there's always going to be one that dips down, and that's called the deep ocean trench. And the oceanic crust will always go under the continental crust when they are moving together here. So the oceanic crust, this is younger because seafloor spreading is making this happen, and these are constantly renewed. We have hot rock here, it cools and hardens, and then it keeps happening, so that little piece continues to move down, and 100 million years later, it comes down over here, it sinks, it melts again, and it's recycled. So then it's down here somewhere, and then it gets caught up in this, and it'll come back up, and it will create a new rock here, and it will be pushed by the new rock that's coming out. And again, it's constantly renewed, and this is the younger rock. This is the younger crust. Over here, this is also made from volcanoes. This is an igneous rock, and it's older because it's not renewed. There's no recycling that's happening here. It's being made, but it's just spilling on top of the crust. So it's just like building up and higher and higher. This is mostly granite, which is less dense, and that's why this one down here is sinking, because this is made from basalt and this is more dense. So I want you to maybe pause the video, look through this, make sure you make sense of all of this. I'll also put it on Schoology. There are two different types of rocks, igneous rocks, that we're talking about here. So there's basalt, and I don't have one of these in the lab here. I have one that has the air bubbles in it, the little vesicles, but it's not, it doesn't look like this, so I didn't really want to show it. So this is dark colored, and this comes from the lava. So once that lava comes out of the mid-ocean ridge and hardens, it turns into this kind of rock, and it's the most common extrusive igneous rock. It is outside of the volcano, and it's called extrusive. That makes up most of the ocean floor. This one over here is from the magma that is inside the volcano, so it is intrusive, and it comes from the magma. So we've got all these crystals here that had so much time to grow bigger and bigger and bigger. And this is mostly found on the crust. So when you put these two together, this one is way more dense than this one here. All right, so grab a Cornell note sheet, or you can just draw this in your notebook, and I'm going to type this along as we go, so I hope this is big enough. All right, so our topic or objective, right now we're in the unit plate tectonics, and we're moving on to plate boundaries. Plate boundaries is about how the plates are interacting with each other. Are they moving towards each other, away from each other, or just sliding along each other? And there is a difference there, and that's why we have to talk about the different kinds of crust. So our essential question is, what is the difference between continental crust and oceanic crust? This is going to be pretty straightforward here. Number one, what is the lithosphere? This is the crust and the upper mantle. And the upper mantle. The crust, wow, I'm having some issues here. The crust is made of oceanic crust and continental crust. Okay. The asthenosphere is still the upper mantle, because there's still mantle below that makes up just the mantle. But the upper part, that is hard and solid. So let's do rigid, solid rock. The asthenosphere is one that's convecting, and we're basically done talking about that now. Okay, here we go. What is the continental crust? It is less dense than oceanic crust. That means that it floats, because in a density column, less dense floats on top of the more dense because the particles are further apart. It's mostly made out of granite, which is an intrusive igneous rock. And the continental crust is older than oceanic crust, since it is not renewed. Okay. So it might be helpful here, after you have written that, to go back to the picture and look at that continental crust. It's older because it's not being renewed with this mid-ocean ridge and deep ocean trench. There's no seafloor spreading, it's just sitting there. And the volcanoes are growing and growing. It's less dense because it's made of the granite, which is made from the magma. And then the other one is like the complete opposite of that. So what is oceanic crust? It is more dense than continental crust. That means that it sinks when it comes in contact with the other crust. It's mostly made out of basalt, which is an extrusive igneous rock. And it is younger than continental crust, since it is renewed, and that process is seafloor spreading. And with seafloor spreading, we have the mid-ocean ridge, which is creating the new rock. And the deep ocean trench, which is recycling the old ocean, maybe oldest ocean floor. Okay. So that is it for the notes. I want you to go down here and write a summary, and the next part is creating a Venn diagram on a continental crust and an oceanic crust, trying to tell the differences between the two.